square, my favorite solving method. If you can't factor, if you can't graph, there's only two ways to solve a quadratic. And that would be the quadratic formula that you just had your quiz on and completing the square. Now, depending on who you had for Algebra 1, you may or may not have done complete the square. You had a teacher. You had a teacher, she just didn't teach you the same way.
No. You had a sub.
Oh, was that the year that she had all her?
Yeah. Although I
know who they're talking about. So, we're going to complete the square. So, depending on when you had a sub for Algebra 1, you might have already completed the square, you might remember. If not, you will catch on super quick. It is not that difficult. You need to understand the idea of perfect squares. So, we know that 25, the number, is a perfect square. Okay, so we know all about number perfect squares, but there are actually expressions, quadratic equations that can be perfect squares as well. Like x squared plus 6x plus 9 is a perfect square trinomial. Now what I mean by a perfect square trinomial is that I can factor x squared plus 6x plus 9 as x plus 3 times x plus 3. And why do you think I call it a perfect square trinomial? Yes, because a perfect square means you take the two terms times themselves. How could I rewrite x plus 3 times x plus 3?
X plus 3 squared.
X plus 3 squared. Right? If I can take it times itself and square it, that's why it gets the name perfect square trinomial. So knowing what a perfect square trinomial is helps us with completing the square because this is ultimately our goal. We want to manipulate our quadratic equation. That's all we're doing is we're going to rewrite it so that we can factor our trinomial to look like this. That's the goal. So let's practice that factoring part first before we actually do completing the square. So we're going to turn each one of these quadratics into a perfect square trinomial. So we're going to make the quadratic specifically what we want so that it factors the way we want to. And here's the rule we're going to follow. We're going to take the b term, and the b term is the middle number. Right? So b is the number in front of x. So we're going to take that middle number, divide it by 2, then square it. So we'll just review some of this really quick. So for example, to create a perfect square trinomial out of x squared plus 10x plus something, you're going to take that 10, that middle number, and like I said, we're going to divide it by 2. Well, what's 10 divided by 2? 5. So you have 5 squared, which is 25. So we chose the number, very specifically chose the number 25, because when I rewrite this equation with 25 as c, something nice is going to happen when we factor. So just to review, we'll only have to factor this formally one time. When you factor a trinomial like this, you need two numbers that multiply to 25 and add to 10. What would those two numbers be? 5 and 5. So when you factor this quadratic, you will have x plus 5 times x plus 5, which is x plus 5 squared, right? Good, so basically what we did here was we very carefully chose a specific number to put in as c so that I got the answer that looks like this. So let's try it again. Let's look at b, and then we're going to see a pattern here in a minute. I'm going to take that middle number, negative 8, and divide it by 2. And I'm going to square it. So what's negative 8 divided by 2? Negative 4, and negative 4 squared is 16. So let's put 16 in for c so we can factor. Y squared minus 8y plus 16. What are two numbers that multiply to 16 and add to negative 8?
4, negative 4.
Negative 4 and negative 4. Yep, which is negative 4, the quantity squared. You should see a pattern arising. The last one's not so nice, but it still won't take very long to do. You might want a calculator, though, for it. I have to take the middle number, -7 divided by 2. What's -7 divided by 2? -3.5 squared, which is 12.25. Okay. So you're going to end up factoring a squared minus 7a plus 12.25, which is not very pretty, but you should be able to guess, based on the pattern and the other two, how this is going to factor. And if not, we'll tell you what the pattern is. What do you think should be after the a's? -3.5. Well, how'd you get -3.5? Yeah, because these numbers that are in your factored form, that is always half of the middle number that you took every single time. The way you get the factored form is by taking half of the middle number. So that's the one thing on that line on the bottom. One thing we take away here. All right, I don't know how I want to say this. The number in factored form is, I'll just say b/2. Right? B is the middle term. So that's one thing I wanted to notice here. The factored form is going to be really nice, and it's going to help us out a little bit later. The second thing I want to notice here is, what do you notice about the C, the thing we put on the end every time? Other than it's the half of the middle square. It's always, that's a perfect square, yeah. And I'm looking for, is it positive or negative? It's always positive. Why do you think it's always positive? Because you squared a number, right? So C is always going to be positive. Even if the middle term is negative, when you square positive or negative, it's always positive. So it should always be plus something. So that helps us, because now to solve these quadratics, we're going to be doing this method. And since we have an understanding now how to jump to the factored form, it'll be a lot faster. You ready to do the one on the bottom? It even says quadratic formula on the side. We're not going to do the quadratic formula because, one, like Jamie said, it's Friday. And I hate quadratic formula. I just do. And it's okay. You guys can do the quadratic formula. So let's look at this. I put the steps for completing the square in the box in the middle. So the first step says you need to divide all the terms by the coefficient of x squared if it is not 1. What that means is I want just plain old x squared at the front of my quadratic. If I don't have x squared, then I need to make it x squared. But here, I'm good to go. We'll see one of those later where I have to fix it. Here I have x squared, so we're going to skip to step 2, which says we're going to rewrite the quadratic as x squared plus bx equals c. Here's what that means. I want to move this constant to the other side. Right, so here's how we're going to write it. I'm going to do x squared plus 8x. Now, am I going to move the 3 by adding or subtracting it? Subtracting it, right? Because it's positive. I'm going to subtract it over, but in place of the 3, I want you to do plus a box, or plus a square, however you want to do it, because we're completing the square. Plus a box equals, I subtracted 3 over, so I have -3 plus a box. Now I have to put a box on both sides, because whenever you add something to one side, you have to add it to the other. Now what we have to do is step 3, fill in the box, fill in the square, by adding b/2 squared to each side. That's what we were just doing up above. What we're doing is we're going to make a quadratic on the left-hand side that factors really nicely. So let's figure this out. We take 8. We're going to do 8 divided by 2 squared. What is 8 divided by 2? 4. 4 squared is 16. So 16 goes in both boxes. Okay, fill in the box. Now all that's left is to factor and solve. But since we designed this problem very carefully, we picked the number we wanted here so it factors really nicely, we're going to get 2 parentheses that are exactly the same. We need 2 numbers to multiply to 16 and add to 8, and we said that that was always going to be half of this number, which is what? 4, x plus 4x plus 4. And I'll even make this faster for you. What's always going to happen here? They're always going to be the same, right? So you can always condense it to make them squared if you want to. So you can write it, I'll write it this way for this problem, but the rest of them I'm going to jump right to the x plus 4 squared, just because it'll save us a little time. What goes on the right-hand side? 13. Okay, so you have x plus 4 squared equals 13, and now all we have to do is get x by itself. How do you get what? Say it.
How did you get from -3 to 13?
Negative 3 plus 16. Sorry, it's hard to see because I wrote it over top of the steps.
So you just have to add 16 to both sides?
Yep.
Ah.
So when it's negative 3 plus 16 gives you the 13. Yep. Sorry, I kind of glossed over that part. No, you're good. All right, how do I start solving here? Square root it. So I'm going to square root both sides. The biggest thing to remember is when you take the square root, technically how many answers are there? 2. So you need to put plus or minus in front of the radical 13. Because remember, we're finding the roots, the x-intercepts of the quadratic, and there's going to be 2 x-intercepts. So I need a plus and a minus. And then all I have to do is subtract 4. When I subtract 4, I want you to squeeze that negative 4 in front of the plus or minus when you write your final answer. All right, that's just the convention. We want to do negative 4 plus or minus radical 13. Does radical 13 simplify? No, so that's your final answer. Got 2 numbers there. Are they rational or irrational? Irrational. Could you have factored that quadratic? No. Okay. You remember that process? Well, flip your paper over. Let's do a couple more here. We'll do like 2.5 more. We're not even going to do, we won't even do all 3. We'll do 2.5 more. All right, this one again starts really nicely because I have a plain old x squared up here. So I do not have to divide anything. I can just go ahead and move my 30 to the other side. And when I move the 30, I'm going to put my box, my square. Right? So I'll have negative 30 plus a box. Now, to fill in the box, just as the other problems, you take that middle number, divide it by 2, and square it. Well, what's negative 10 divided by 2? Negative 5 and negative 5 squared is 25. So I'll put 25 in both boxes. Now, because we can see where this is going now, because we remember, and we've done like 4 of these at this point, I'm going to jump right to the condensed factored form. If that bothers someone, I'll spread it back out and show you what we have. But how is this going to factor? X minus 5 times x minus 5, which is x minus 5 squared. Right? That number in the parentheses is always half of the middle number. That's just how it's always going to work. What's the right-hand side going to be when I add those up? Negative 5. I give 2 more steps. I like this. I just like this better than quadratic formula because you don't have to type 5,000 things in your calculator and make sure you have parentheses around things. You just kind of go. All right, so I will have x minus 5 on the left after I take the square root. What do I have to make sure I put in front of the square root on the right? Plus or minus, and then we'll have an I. Yeah, what's the square root of 5? Negative 5. I radical 5. Yeah, you need to see that, remember. Good. And then I move the 5 over by adding it. So x is our answer, 5 plus or minus I radical. Now, those are imaginary answers. Would that graph cross the x-axis? No. And so you couldn't factor it. All right, are we okay with that one? All right, we're going to do one more full one, and then we'll do like a third of one. We're going to do the whole last one. This one, 3x squared minus 8x plus 4 equals 4x minus 2. What do I have to do here? I have to do what? Yeah, move the 4 over. And then what else? Yeah, move the 4x, and then Bobby said also move the 4 to the other side. We can do that. So I can move the 4x, and I'll move the 4 at the same time. So the constants go on the right, the x's go on the left. Kind of do 2 things at once. So we'll get 3x squared minus what? Minus 12, 8x, we moved the 4 over. So minus 4x is minus 12x. I'm going to put my plus box here. Because then I moved the 4 over, equals negative 6. Are we okay? That we did a lot of stuff in one step there. If need be, you can move everything to the left and then move the constant back over. But we okay with that step? Yes, KJ? Yes. That's why you raise your hand, right? Yes, we are going to have to divide everything by 3 because we don't like that x squared here. So I want you to divide every term by 3. You can skip over the boxes. It's tired. It's the end of the day. So we're going to divide. You can skip the boxes because nothing's in the box yet. That's just there for like a placeholder. Divide everything by 3 because otherwise we can't do complete the square. So we'll have x squared minus 4x plus your box equals negative 2 plus box. And now it should look just like what we were doing on the other problem. So what's going to go in your box here? You take negative 4 divided by 2 squared. 4. Great. Put 4 in both boxes.
Wait. Oh, wait. No, never mind.
Okay. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. That's how I filled in both boxes. Okay. No, you're okay. Ask any questions you have.
I keep going too fast in my brain and then I trip myself.
Now this is going to factor, but remember the factors are always going to be the same, so I can skip right to the condensed factored form. What is going to be in that condensed factored form? X minus 2. Yep, half of the middle. Equals negative 2 plus 4 is 2. All right, square and add, and you're all set. Square root, I mean. Square root and add. Same thing. We square root, we have x minus 2. Equals, what do I have on the right-hand side? Plus or minus the square root of 2. And then I'm going to add 2. All right, would you agree that that is not too bad, and it's actually pretty a nice method? Yes? Nate doesn't like it? No? I don't remember if I taught you that in Algebra 1. I think I did your freshman year. I taught it. Pretty sure 2 years ago I taught it, and then we stopped teaching it in Algebra 1. No, with I. Yes, not with I. All right, now, here's the last one. We'll just do a little bit to start here. I have 3x squared plus 5x plus 6. Can I do the quadratic formula yet? Not the quadratic. Complete the square yet? No, I have to divide by 3. So let's divide everything by 3. Including the 0, because technically you have to divide every term by 3. And you're going to get x squared plus 5 over 3x plus 2 equals 0. Uh-oh. Yeah, oh, I know, we're not. We're not. Do you like that? No, because here's what's going to happen, and you can stop writing if you want to. Just watch for a second. What's going to happen is you will have x squared plus 5 over 3x plus your box equals negative 2 plus your box. And in order to fill in that box, you're going to have to take 5 over 3 divided by 2 and square it. Does anyone want to do that for me? I know what the answer is, but it is going to be 25 over 36. But do you really want to deal with the fractions 25 over 36, adding that to both sides? No, I don't either. Let's figure out why that happened. What do you notice, and I'll flip that for you. The very first problem we did was the middle number even or odd? Even. The next problem we did, middle number even or odd? Even. The next problem we did, middle number even or odd? Even. This one here.
Oh,
that's okay. Yeah. Even, right? Now, complete the square seemed to work okay when the middle number was even, because when you divide by 2, like an even number divided by 2 always gives you an even number. Well, this one had an odd number in the middle. That didn't work so well, right? Right. So it seems like even though I love complete the square isn't always the best option, which we're going to talk about more next week. It's actually going to be easier this time to use the quadratic formula. I'm not going to make us do that, but There are certain cases where complete the square, even though it's lovely, is not best. All right. So good work today. What you're gonna do